Welcome to the lecture series. So in the previous series, we have discussed about the biological neurons and artificial neuron models. And now we are going to continue with the single layer perceptron classifier. So what is this single layer is? It is the simplest form of artificial neural network forming the foundation of more complex neural architectures. So you can find here we have the inputs starting from 1 to xn, and we have only one layer of the weightage given like w0 to wn, and we have the summation part, activation part, and the output. So first thing, we have to understand the function structure of the perceptron. We have to analyze the mathematical model, and then we can implement through learning the algorithm, and then apply the learning algorithm to solve the problems, and then identify the real-time applications and their limitations also. So now coming to the understanding part, here it understands needs for the classification. So first step is, we know that is for supervised learning, classification is the basic thing we have to do, and for this classification the understanding of the user need is very important, and identify the different data patterns is also important, and we have to use the binary classifications. And next we have to go for the problem statement, like what is the real perceptron needed, and then we can give the single layer or multi-layer. So now coming to the activation functions, you can see we have the inputs, weightage, summation, and in activation part greater than 0 means 1, and if it is lesser than 0 means it will be 0. So these are the two functions we do it in the activations. And in the summation, you can see we will multiply the weightage into input plus biasing. What will be the biasing, that is also included. So this is the basic format for summation, and this is the basic format for your activation. So these are the basic functions of your summation and bias and activation factor. And coming to the single layer, we can see input layer, weight, and only output layer. So only one weightage layer will be calculated here. And perceptron is nothing but the simplest form of artificial neural network, and this is it invented to serve a linear binary classifier. It acts as a linear binary classifier, and it consists of the input nodes and weights and output node, and it uses the step function as the activation. So whatever the activation we can do, but here it uses only step function, either 0 or 1, and can solve the linear separable. Yes, it is 0 and 1, so it is linear. So we can only use for the linear problems. And we have the input layer, which receives the feature of vectors, and we have the weights, and this connects the strengths between the inputs, and summation function calculates the weighted sum, and activation function, it uses the step function for binary output, and bias is nothing but the threshold value for the decision boundary. And finally you can see it is calculated using the y is equal to function of summation of weighted into input plus bias. So the binary classification, we can find either the output is 0 or 1. This is the basic single layer perceptron architecture. And perceptron learning of algorithm is, we have to initialize the weights, and for each training compute output. For each training we have to get the output, and we have to compare this output with the actual label. Once the comparison done, we have to update the weights based on the prediction error, and once it is done we have to repeat for until it is convergence. So we have learning rate, which is typically from 0.1 to 1.0, and weights only updated when error occurs. And we have the algorithm stops when all the examples classify correctly. These are the basic things we have to know about this learning algorithm. And next, coming to the key points, yes, we know it has only consists of a single layer of weightage, and here you can see in the activation function we usually use the step function, right? And we have unit step, and we have linear, logistic or sigmoid, and hyperbolic. So for each in function we have the g of z. So g of is nothing but the function of the activation. So in step, if it is greater than 0, it will be 1, otherwise it is 0. And in the unit step means it will be 1. If it goes for minus, it will be 0. And we have the step input. For linear it is z, and logistic it is 1 by 1 plus exponential of minus z, and for hyperbolic exponential of 2z minus 1 divided by exponential of 2z minus 1. So from this we can know it can be used for the robotic visions, pattern recognition and decision boundaries. So only thing we have to do is weight update rule. That's the only thing we have to follow here. We have to find out the input factors, calculate the weight, update with the weight, sum the weight and update with the weight, and then go for the final convergence. So in the next lecture series, we will see what are the limitations of this single layer perceptron architecture. Thank you.